Hello, everyone. Welcome to the April edition of Show and Tell Monthly. This month, we've got some really rad new projects to talk about. We've got Goran Mahovic's Zigzag, Jonathan Broadwell's Serial Wombat, and Juan Sulca's Tinkerpod. So we're really excited to hear about these projects and how they all came together. But first and foremost, we do have the Open Hardware Summit coming up. We're a little bit over a month out. So we're first day is May 30th, second day is May 31st, happening in Edinburgh, Scotland, as well as virtually. So you can also tune in from anywhere around the world and get to see all the talks live and participate through Discord and other online means. So if you are thinking about it, now is a good time to finalize your plans if you're traveling, or to figure out your virtual setup if you feel like doing a stream party with some friends or something. So really looking forward to that. Our full schedule is out at 2025.oshwa.org if you want to take a gander and figure out what your open source hardware summit experience could look like, because we've got some really awesome talks, workshops, panels, and tables this year. So it's going to be a pretty packed schedule. But for today, we're going to be talking about some really cool new projects. So we're going to start with our friend Goran. Hello, how's it going?
Hi. Yeah, cool. Thanks for calling me. So it was a pleasure to be here. So
we're so excited to have you. We really love the work that Radio Anna gets up to. So really stoked to hear all about the Zigzag.
So yeah, I didn't prepare the presentation, but I have like few websites, and I will show like GitHub page and the product itself, like the Zigzag. So and I will explain like how it how we did get to a Zigzag. So I don't know if this is like now okay or it is like inverted.
No, looks good to me.
Okay, then I can like that's cool. So I am from like Zagreb Makerspace, and like there is lots of text here, but we are not just the makerspace. So we are doing lots of things in our community. So we have lots of workshops. We have like repair cafes. We have like also one camp, and we are like quite diverse community, and like there are hackers there are like artists, electronics, and really like lots of good people that are like hanging out and doing like great stuff. So that's like the Radiona. And like from Radiona, so at one point we had like one product. So we formed, three of us formed a company. It was like for the ULX3S, and this is also like open source hardware certified product. And like we had really like opened the company Intergalactic, and it was like really successful campaign. And but here I will talk about the different project. So the first thing was that we are often on the like security conferences, and we are mostly there to like give a talk or hear others talking, but sometimes we are also there to show some things. We have like retro setups and stuff, and this time so we had like retro setups at B-side Zagreb, and they asked us for to design some kind of badge for them, because it's like on the conference you need to have like at least a non-official badge, and this was our badge was like non-official badge. So we decided to do it like not more for this conference than to have like universal badge that will be for the security conference. So when I was like last year on Balkan, they have used the badge that is using, just a second, I will now switch to me. So they have used the badge that is using the small like RISC-V microcontroller, and it is really cheap. That is like 10-cent microcontroller. So and later I have found out that Olimex has like also open source project that is like RISC-V PC, and the project cost of the RISC-V PC is like €1. So So me and Damir talked about it. Damir is like a designer from Radiona who designed the zigzag. So we talked a little bit, and we wanted to have something. Okay, just a second. So we wanted to have something fully simple, but that can have some like task to solve and some like capture the flag moment. So we have maybe this is the first one. So we have designed. So he designed the front page, and he guided me to like some things that we could do with like task and stuff. So what we have imagined, so if we use some kind of display, that will be like more expensive. So we just wanted to go with like few LEDs. So we choose the like just 5 LEDs, and with five LEDs we can do really a lot of things. So you have, so on this page we have like how it's called, but I know on Croatian, but on English, like it's called like perception of vision. So when you have like few LEDs and you just like move the badge, you will get some like you can write letters or numbers or whatever. So this is like one way of showing something to the user. So on this badge, it is not visible when you just like pull the badge up and down, so it needs to be fast. So we are using like long exposure to get the image. And the second thing that we did on this badge was like blinking in Morse code. So with that kind of stuff, we can give some like presentation to a user. We give some information to a user, and user can have like inputs. And for the input to the badge, we use just one button. So, and with one button, you can do lots of things. You can like switch the programs. You can do many things with just one button. So also we wanted to do it like so it is assemblable like with hand, but as they wanted to have like 100 badges, and I wanted to assemble it like in Croatia, so I have used like simple homemade stencil. And this is like a few times before I have used this technique. It is like the stencil are cutted from the pure paper, so it is like ordinary paper. It is just in color because it's easy to cut with a simple laser. So I just cut the stencil, and I produced like around, I think, 100 badges for this conference. It was like in last minute, so I spent like all night producing the certain amount, and I have like 40 more to like fix because it was not like perfectly done at that point. And then I had like some simple we had written like simple software, so it's like fancy rider, like Morse code, this perception of vision, and switching to different stuff. And we also put the power off, like go to sleep mode, so the badge can hold like a few days inside of the sleep. We didn't go design the full sleep mode, but just like simple one, so that we don't blink LEDs and stuff. And what else I have here? So on the conference, it was really cool, and few guys were really hard stuffed into the badge, but the task was really complicated one. So it was so we had the 2 badges with 4 messages, and fifth was like 4 messages were encrypted, and fifth was 4 messages were encoded, and fifth one was encrypted, and there were 2 keys in 2 different types of badges, so it was like really complicated. And only one guy managed to do it. So it was like, you don't see it. I think you don't see it here, but it was Jurica Radovic. So he managed to do it in the like 4.5 hours of the conference. So it was like really hard task. So for the next conference, we are thinking about like lowering the amount of work needed for the getting the badge. Getting the results out of the badge. So that is this, and maybe now I can switch to myself so that I can show you. So the first prototypes of the badge was looking like this. So it was just LEDs here and all like doing with the wires and like button. And I did like this for the programming. I put this one so it is easier. This is like and the working badge is looks like this. So it is still like in like first version, so there is lots of things. I didn't even remove from the RISC-V PC. I didn't remove some things like the buzzer and stuff. So because I wanted the badge to be like hackable, but I will see in the next version because there are things I need more space and to put battery on different side. So this is like just a roller, some fancy blinking, and then I can switch to the mode like this is now Morse code, and this is one message, second, third, fourth, and fifth, and then we can have like this perception of vision when it's when the long exposure is done. And on the task, it was like on the long exposure was the clue for the encoding and for the encrypting, exactly for decoding and decrypting, and on the like blinky Morse code, it was like a task, and more or less that's it about the zigzag. So yeah.
That's awesome. It's such a cool, like, every year we're trying to figure out what our badge is going to be for the conference. And we've been trying to think of more sustainable ways to approach it. Cause like, even though we have some like really fun ones, I think I still have a couple of mine back here. Yeah, I've got like last year's badge. This was a really fun one. And we had like a whole bunch of stuff for like hacking this one. And we've got this one's 2023 and also 2022 or 2020. And they're always so fun, but yeah, they you end up having them for one event, and then you're kind of like, oh, what do I do next? So something like this that you can reuse is so important. We're really excited about our badge this year, but I think this is definitely something that we might think about for another summit year.
Yeah. Because we were always also thinking about this. It is almost never reusable, and it is mostly like it goes to like high price. And we wanted to design something that is like just a basic that has like lots of options for the expansion. So that was the idea.
Yeah. So what was, or actually, is it cheating if we find out what the final encrypted message was?
It isn't cheating, but it is not like on the GitHub. So it was like really simple. It was like, I think, I don't remember exactly, but it was like zigzag your personal security badge or something like in that. So, yeah.
Nice.
But it was really complicated because there were like two keys. Like one was on the, because I have with the blue LEDs and like with the red LEDs, you know that blue and red team in security, that's something. So I had like two keys. You needed to get two keys to, so it was like crazy. So that guy spent the whole conference in decoding the badge. So, but he got the prize. So it was like it was available prize, and I think he will get also the job because he was only one between like 200 people to
That seems like a good job interview task.
Yeah.
The encrypted one. We also have a comment from San here. Fun design. I always love creative use of PCBs. And we agree. There's always so many fun ways to utilize PCBs and make them more interesting than just a square. So it's always fun to see these fun designs that people have been coming up with these days.
I also didn't show like we also have like different types of like badges. Like this is like our like badger.
I love that.
Yeah, and this is actually it shouldn't like blink. It was an error. So we have only one blinking LED because this is only LEDs. It doesn't have microcontrollers. So we have one blinking LED, but when this LED like starts, it is like powering off other LEDs, so it also blinks. So it was like a wrong design that turned out really good, actually.
Yeah. Sometimes a little mistake turns into a fun accident.
Yeah.
Happy accidents, right? That's the,
Mhm.
or as my dear friend Saad likes to say, it's not a bug, it's a feature.
Yeah, exactly. In the second version of this Blinky, this is Ori, our Radiona's for the repair cafe, Radiona's mascot for the repair cafes. So it is like on the second version we implemented so people can put different types of resistors and get one version with the whatever blinky eyes, not blinking, and different stuff. So it is like now it is a feature, but
Yeah,
it was a bug.
So do you expect to have, you're saying you're thinking you're going to do another version of the zigzag?
Definitely, yeah, definitely. I will have another version on the next balcon, like this year in I don't know where, in 9th month. So this will be the second version. I will try to get a talk there, and maybe in also in 9th month in B-side Zadar, because like that's also one security conference.
Yeah.
And there will be new message that will be encrypted, and it will be like more easier. So for the balcon, maybe not, because there is like 3 days of hacking, so they will have
they'll have a lot of time.
Yeah. And lots of like stuff to hack. So
yeah, maybe it needs to be harder then. If they have 3 days, maybe it
yeah,
needs to be
yeah,
even harder encryption.
Be harder. And I am thinking like to they have like, that's also like fully open source. They have like this badge from the, I think they will have the same badge on this year's conference, maybe few different things, but on this badge I think that I will combine something on so you will need to get messages maybe from this badge and then do some things. So yeah,
That'd be very fun. I do remember seeing I mean, oh, gosh, what badge was it? There was a conference where I remember the badge reacted to other people's badges. And
yeah. I have also one. I have also one from the like Makerspace member.
Yes, this is the exact one I was thinking about.
Yeah, that's also cool. And for this year, I think maybe he is also on the stream. I send him the link. So I think this year he also has different design, but in similar manner. So yeah. So
yeah, such great designs. So fun.
Thanks.
Do you see anything else on the horizon for the zigzag? An update, and then what kind of features are you trying to add at this point?
There is like lots of things. I would like to have more like inputs on that, like one button, because like one button can do many things. Like you can have a keyboard with one button, maybe something like solving the puzzle on the badge, because now you're just getting the messages and you will need to like write them down. But I am thinking about like you have a task and you need to fulfill the task and enter the message inside of the badge, so you can like clear the task and you can go like in the task. So you have like first task solved, second task, so the badge could show like that you solve all the tasks, and you can have it on the like conference and have at the end you can have like Blinky as a gift, like as something. So
yeah,
but yeah, more input stuff is needed, and maybe like to think about more output things with the 5 LEDs. So that's also something cool.
Yeah,
maybe different type of font to look nicer and stuff. Yeah,
makes sense. All sounds like really great stuff to add too. There's always so much you can do. There's so much you can do with the PCB these days. Thank you so much for coming on and giving us a bit of a rundown on the zigzag, and looking forward to getting to see it in person sometime soon, hopefully.
Yeah, hopefully. Yeah, thanks.
We'll talk to you soon, Goran.
Bye.
What a rad project. I love PCBs and fun designs. It's always really neat to see the way folks are approaching PCBs these days. We have so much more we can do with them now, and it just means that we just get to see lots of really fun shapes and designs and creations. Next up, we've got Jonathan Broadwell, who's going to tell us about the Serial Wombat.
Hey, okay. So my name's John Broadwell, and by day I do embedded systems consulting and medical device development consulting. My company, Broadwell Consulting, and at night I work on open source hardware and software. And the kind of premier project, the thing that's kind of been my passion, definitely over the last 5 years, and had an earlier iteration 20 years ago, is called Serial Wombat. And essentially, Sid, could you pull up the share?
Yeah.
So the gist of this is I create firmware that goes into these chips. And the firmware is designed for the end user to, in most cases, leave alone, although it's open source, so you can modify it if you want to. And it makes these chips act like GPIO expanders that you control over an I2C bus. And so, there's already a lot of chips out there that do that. We'll talk about that in a minute. But essentially, once you take, this is a PIC 24F, this is a PIC 16, and this is, my new jam. This is a CH32, which may be the same 12-cent RISC-V microcontroller that Goran was talking about in the last thing. We're I would say 6 months to a year away from seeing these things really explode, because they're starting to get critical mass out there with the tools to help with them and enough documentation to make things go. And I'm hoping that the Serial Wombat's firmware will be a good reference for people as well. I try to document it well and whatnot. So the Serial Wombat 8B is currently a Kickstarter. I've got enough support. Since I took the screenshot, we're fully funded, but we'll be creating a lot of different boards. Yay! We'll be creating a lot of different boards, variations on this. And the target on this guy is going to be under $1.50 per board, shipped and programmed. And so that'll put it really in competition with single purpose IO expanders, because this micro is so cheap that in some cases, even coming from a maker like me, we can undercut, the chip prices coming from some place like DigiKey for one of the competing things. So, I'm very, very excited about that. So why does the project exist? And I spend a lot of time on the forums, particularly like Facebook groups that support, Arduino for beginners and things like that. And one of the things that I see over and over again is people who come into the open source hardware, firmware area, the Arduino place, the MicroPython place, sometimes Raspberry Pi, and they're not electrical engineers. They're not computer science people. They're not even really necessarily electronics people. And that's not why they're there. They're there because, okay, I want to animate some aspect of my model railroad setup, or, I'm really a Halloween display enthusiast or something like that. And they have a friend who told them, oh yeah, no problem. You can do that with Arduino easy. And it's easy if you have a 20-year background in computer science and embedded systems. And what these people typically find is they get in and they do the experiments, or they download some code, maybe go to the examples in the Arduino library for something like, say, take the DF Robot MP3 players. Everybody loves them. They're super for, Halloween displays and things like that. But a critical item of that is that the example that they show uses what's called software serial, which emulates a serial port using bit banging, so that you can keep your main serial port still free to talk to the PC and whatnot. And the sample example works great. But then what happens is people say, oh, okay, I want to play a sound when I move a servo. And they run into these roadblocks where all of a sudden everything got glitchy. My servo's jumping back and forth, and sometimes the sound doesn't work. And what they don't, what they've run into is kind of the limits of what you can do in an easy environment, because the Arduino shares its interrupt timer structure between software bit banging the UART and generating the pulses that go out over the servo. And so when two of those things need to happen at the same time on the timer interrupt, then you get glitches. And for somebody who doesn't understand deep embedded systems and resource contention, they have no idea what's going on. They assume it's their code, but in reality, it's an architectural issue. And so, but one of the things that I've tried to do is make it so that you can offload a lot of the things that beginners want to do. You consistently see these problems where people say, I can do A and make it work great, and I can do B and make that work great. But when I try to do A and B together, I have a lot of problems. And that's, a lot of that's based around the concept of like Arduino people use delay a lot, where you're just blocking the microcontroller, and you can get around that by doing state machines and all kinds of, moderate level embedded systems constructs. But again, that's a hill to climb for people. So my chip I've looked at a lot of these problems that people have where they're trying to do synchronous tasks that, if you don't know how to structure your software real well, kind of tie up and can be the only thing you can do. And it allows you to take those tasks and hand them off to another microcontroller. And so, like, for example, if you're ticking a rotary encoder, you have to catch every single transition in order to not have it feel glitchy. With the Serial Wombat firmware, you can offload that and say, okay, Serial Wombat chip, you've got a rotary encoder on pins 2 and 3, and I want you to keep track of the net result of the number of turns. I'll check back with you later, and all I'm going to ask for is how many turns have changed, as opposed to you have to have an interrupt that fires every time the user clicks that thing, because usually you're not interested in the interrupt. Sometimes you are for timing purposes, and the Serial Wombat chip can take care of that too. But typically you're only interested in what has the net result been since the last time I updated my user interface. So basically, there's already a lot of popular I/O expanders out there in use. One of the most common ones is the MCP23017. And basically, it's just, it's a way to add more I/O, but they're relatively dumb I/O. High, low, input with a pull-up, and then you could set it up so that one of the pins pulses on change so you could fire an interrupt on your Arduino. And essentially, the Serial Wombat chip takes and builds on that, because all of the things that normally you would be doing either in a push, constant update, or in a poll mode, it tries to do that on chip and provide you with the net result. Again, the rotary encoder being one example of that. Another chip that is very popular is the MCP3008. It's an ADC off-board chip. You see people use this a lot with the Raspberry Pi. It's kind of, the basic easy one to do. People use it with an ESP3266 because that's got a very poor A to D converter on it. My firmware then exposes the ADCs again. And so you can set it up and you can say, hey, I want you to take a sample every millisecond, but average 64 of them together, so that when I ask you, I get a nice average sample, which also gives an appearance of an increase in resolution. And so, and you can configure each of the pins as a different state machine, so that you can say, okay, these 3 pins are going to be ADC, these 2 pins are going to be PWM, these 2 are, are monitoring a rotary encoder. And so the chips that I'm showing you right now that you might buy in pre-assembled boards off of Amazon do one thing. My chip is designed to allow you to mix and match the pins over the I2C bus in a way that lets you do all those things. So we just looked at the PCA 9685. When people want to control a lot of servos, they typically use that board because it generates PWM outputs that can control the servo. Well, I can do that as well. And the thing with this board is, if you want to move the servo, you send it a new I2C address. One of the common things that you may want to do is make a servo move slowly for animation or robotics purposes. With my chip, you can tell it, okay, you've got a servo on pin number 8. I want you to go to position, 120 degrees. And then I want you to move to 180 degrees, but you're only allowed to move 15 degrees per second. So the chip itself, you send it a set of commands and it moves your servo over time. So again, what you're taking what would normally be a real-time synchronous operation that somebody would have to code on the Arduino side, and letting the chip's firmware, the off-board microcontroller, take care of all that. So it acts as a real-time coprocessor as well. You can configure the pins to interact with each other. So like if you've got one of the pins configured to be a speed control, then it can feed into another pin that is a PWM output. And you can say, okay, I want you to measure pulse frequency on pin number 4, Pin number 5, I want you to make a PWM, and I want you to configure the two of them together with a PID loop in the middle. And here's your PI and D constants, so that the chip itself becomes an off-board real-time feedback system. And again, you could do all this stuff on the Arduino, but if you're talking about, say, you've got a four-wheeled robot and you're trying to keep all 4 independent wheels rolling at the same speed at one time, for a beginner trying to run 4 simultaneous PID loops on an Arduino Uno is a bit of a lift. So this allows you to offload all that. So, and here's an example. In this case, we're doing force feedback. There's a current sensor on this servo. And so the serial wombat chip is taking and looking at that force feedback, closing the grippers until it sees a certain amount of force on the gripper and stops. So, there's a YouTube video up on this, but in the example, you just say grip or not grip. And by sending the right configuration settings down to the serial wombat chip, it handles all of the real-time control for you. So that's something that I get kind of a kick out of. So I gripped a bunch of different things, but you don't need to see them all. So here's another example. You can see here, this is running a motor that has a set of Hall encoders on it in quadrature encoder mode. And we're going to a specific position and then stopping. And so you tell the serial wombat chip, drive the motor, to position 8,000, and it moves automatically. And all of this happens. This is a kind of a structural diagram that shows what's going on through the way that you can configure the various pins together. Anybody have any questions up to this point? I don't see anything in the comments.
Not a question, but a nice comment from San.
Oh, yeah.
Very common problem, very well thought out solution.
Thank you.
And I agree.
So, and there's library support around this. One of the things people I try to pattern myself after are the Adafruit people who do a really good job, not just producing a chunk of hardware, but providing well-documented, comprehensive, well-tested libraries. I try to do the same thing. So I start typically with the Arduino library, then I port it to Python and MicroPython and to C#. And one of the things that I do is all the libraries have what I call congruent interfaces, meaning that when there's a class, that class has the same interfaces across all of these libraries. It has the same, parameters to functions and enumerated types and all that. And of course, the syntax is different because the languages are different. But I really try to do that because my goal, if this can grow into a community, is to have people who create something in Arduino be able to look at an example in Python and say, oh yeah, I see how they use the chip there, and be able to port that code back over with minimal effort. It also means that if you design a piece of hardware around the serial wombat chip, you can pull it off of your Arduino Uno, hook it up to your Pi Pico, switch from Arduino to Python, and still have that software up and running in no time. So the serial wombat 8B is the new guy that I'm really excited about. And again, it's around this 15-cent micro. The goal for the board you're looking at here is going to be to get it out for $1.50 about per board in small to medium quantities, like Amazon retail quantities. And this board right here is the one that's been certified open source by OSHWA. And I'll have others that are coming down the pipe as I finalize those designs. And again, we talked about it. This one provides 8 pins over I2C. It has an I2C bootloader, so that once it's been programmed, it comes pre-programmed from me if you buy them retail, or you can program it with the CH32 programmer. But once it's up, you can reprogram it in circuit over I2C to modify how the pin modes work. You don't have to do that, but you could if you wanted to. So, yeah, we talked about that. So I've been working on a lot of integrated board variations. Another problem I see is people get on there and they're like, oh, I want to control these robot motors. And the issue that they have is, okay, now they have to go out and get an H bridge. Which one? There's 7 or 8 you can pick from. Typically, people pick the L298N, which is an antiquated, not great chip, but has a lot of momentum behind it because there's so many examples. So what I tried to do is create these boards that solve a lot of these common beginner problems. Like you can see up here, this one up here is designed for the PID motor feedback control. This is a variation of the board that has all tie-down terminals for people who are not interested in soldering. This one integrates one of the OSHWA boards so that it can have its Arduino right on the board along with a couple of the serial Wombat chips. Sometimes you see people who say, oh, I need to control a whole lot of relays. And so this particular board combines 8 of them so that you get 64 I/O in a single board. And the goal on that one is to sell this board for about $6. So, it kind of goes places other people can't. This is a board. These are 4 Allegro current sensors. So you can hook up 4 servos to this thing and get force feedback on all 4 of the servos. This is what I used to do the gripper example, and and it works great. So really excited about that. And we have about 5 minutes left here. Come on. So the other thing I have is I've developed a tool called Wombat Panel. It's Windows only. I'm not primarily a PC program. That's the .NET Forms is what I know, so that's what I made it in. But essentially, it allows you to, if you load a bridge application onto an Arduino, it allows you to talk to the chip in real time so that you could experiment with your hardware and get it working by pulling, virtual knobs and levers and all that, and set up your PID controller and all that kind of stuff. And then once you have it, you hit a code gen button and it automatically generates configuration code for Arduino, so that, that all of the different parameters and stuff, after you've done this a couple of times, you can be up and running on a new project in, 10 or 15 minutes. The other thing I've got going on is there's a comprehensive protocol analyzer for the protocol that goes over I2C for the Salier brand of logic analyzers in their logic software. So that's very helpful to me. It's helpful to some people when you get a little deeper and it's like, oh, things aren't working. I can tell you, grab one of the generic knockoff Saliers and give me a logic analyzer capture of the I2C bus, and I can tell you what you're doing wrong. So that's pretty helpful. So lots of documentation up on GitHub Docs, all based on Doxygen. We pulled the documentation directly from the thing, and lots, dozens of YouTube videos support examples at this point. So really excited about that. So that's about the size of it. Got a few minutes left if anybody has any questions or comments.
So I'm going to say that these are some crazy embedded engineers.
Yeah.
Yeah, this is quite a whole system. Like, this is an incredible ecosystem that you've developed at this point.
Thanks.
That, like, so many of these things you have built in are like, yeah, these are the things that are often being the kind of problems that we're bumping up against and not sure how to fix when we are new to these kinds of ways of developing hardware. So this is such a great ecosystem.
Yeah.
How long have you been working on the Wombat? So
a lot of the concepts come from the first iteration that I did early in the 2000s, which was hindered by tools and by the cost of microcontrollers and fulfillment options and all kinds of stuff. But this iteration started with a PIC16 8-pin chip, went to a 28-pin chip, and went to this one over about the last 5 years. So, they share lots of the code across them. So the more I do, the more momentum it's gaining. And then I leverage a lot of this stuff in my consulting business so that, when somebody needs a prototype of something turned around, I can pull a lot of this IP that I've already created and integrate it into that.
Yeah. What a great way to solve 2 birds, 1 stone situation. What kind of stuff are you hoping to see develop with it as you keep working on it?
I mean, I see a lot of people who use them as I2C to UART converters, and I've got a guy in Alabama who's working on a music-based Tesla coil thing. He does stuff for kids museums and things like that. So that, and just I'm not seeing. Honestly, people don't contact me as much as I'd like and I don't know if that's, because they're buying the things I'm selling them, but I don't know if they're buying them and not using them, or if they're hesitant to contact me, or if my documentation's just so good that everybody's, no problems here. But, if you actually use one of these things, send me something, let me know what you're up to. But, a lot of it is just those, kind of mid-level Arduino type projects where you're not necessarily coming up with something that's totally new and unique, but it's special and customized for that person. It's exactly how they want their train set to work. And that's, that's really where I think the value of it is.
Yeah, absolutely. There's something really nice about making bespoke tech and hardware that is like specifically for your exact situation. And it's so great to have something that really helps facilitate that and like help people really get to customize in a way that a lot of other things are a little bit more top level, or you're not really getting into the weeds of it a lot of times. So this is such a great solution to like getting folks to really engage in new ways. I also just really love this wombat. He's great. Yeah. Do you have anything else you want to add before we wrap up?
No, just I'm only fulfilling right now to the U.S. because some of our import-export stuff has been a little dicier than normal lately. So, but if you're in the U.S. and you're interested in the Kickstarter, hop on over there and support it. I really appreciate your support.
Yeah. And then also congratulations on having incredible documentation, because I think that's
Thank
what
you.
it is.
I take great pride in that.
Which is a huge thing. Documentation is everything. So when folks have good, strong documentation, ooh, we love it.
Okay.
Thank you so much for coming on today,
Thanks for having
Jonathan.
me on.
We'll talk to you soon. Bye.
Bye-bye.
Okay, another really rad new project. Well, not that new. I guess it's actually been in development for so long, and it's really such an interesting way to approach it, to kind of hit that area where folks are wanting to do a little bit more and need something a little bit more customizable. So our final guest for today is Juan Silka, who will be talking to us about the TinkerPod. How's it going, Juan?
Hey, hello. Good afternoon. I'll share my screen. Let's see how that works. Okay, perfect. Can you see my presentation?
Maybe it's loading. So far, I'm getting a blank screen. I'll try re-adding it. Still a blank screen. Interesting. Do you want to give it another shot of sharing it?
Yeah.
Then you can also figure out another solution if needed.
Yeah, just do entire screen just in case.
Yeah, that might be good.
Do PowerPoint. Is it working now?
Still getting a blank screen. How fun. Do you want to drop the link to the PowerPoint in the chat, and I can try sharing it?
Sure. So, or I'll just give it one last try.
Yeah.
PowerPoint, and yeah, it was like quite last minute, so I'll give it one last try. Hopefully it works.
As we say, nearly every stream, for some reason, this is very complicated. Every computer is different.
Oh, yeah, technology never works as expected.
Okay, yeah, still giving me a blank screen, so that is fun and cool.
Yeah, so anyways, we can continue without it.
Okay.
So yeah, basically, my name is Juan. I'm about to complete my master's on design at OSHWA University in Toronto, Canada. I'm part of the Digital Futures program, and the TinkerPod was developed as my thesis project. Basically, to complete the program, I'm mainly my background is basically in creative coding and software engineering. I've been doing mainly software for quite some time. And I remember I have a YouTube video, so I'll share that YouTube video with you so that you can share it. And I think that will be as good as it gets for this part. So yeah, I sent it on the private chat. If you can share that one, that would be awesome. And the music should be copyright free. So so yeah, it's a bit of the making. So I was trying to make this device a bit of a playful and fun exploration on hardware. So I'm fairly new to building hardware and electronics. It was through the program I'm taking that I set out to design this project. It's built from my inspirations were mainly around devices like the Flipper Zero or the Little Bits. I remember studying a bit of those and being amazed at how great the Little Bits are. And thinking like I would like this modularity on a device I want to make. And I'm finishing loading these to the thing so we can have a presentation, because I think it's quite hard to like see it without seeing the presentation itself. So just give me 1 minute. Really sorry about that.
Oh, it's fine. It was just the way it goes with sharing screens. I don't know why, but it's
Yeah.
actually the most technically difficult thing that anyone has ever done. It's right up there with printers. Can't get a printer to work, can't get a screen to share. We'll just never know.
Yeah, it's quite unexpected sometimes. So yeah, basically I was trying to build this device from scratch. I started around the last summer. So trying to make it like into something that exists into the world and face quite some challenges. But it was quite fun to do so. And I'm gonna share the link now. And I cannot see my own files. Amazing.
That's what I'm saying. We just don't know. The mysteries of technology are always going to win in the end.
Yeah. It seems that today it's not exactly. Oh, finally found it. Amazing. Okay, perfect. Now we should be good to go. Really sorry about that technical difficulty.
No problem.
So yeah, you can start at like I think it's number 7 on the slides, because we already saw the video.
Sure thing. So it's going to.
Yeah, you can move to the next one, the one after the video.
Now it won't let me exit the video. Okay, I'm going to do like this. And just go to slide 7. Okay.
Oh yeah, number 6.
6.
Possible, yeah. That's perfect. Yeah, so
We'll do that.
yeah, so these were my inspirations for making it, from the little bits on like the modularity and the way it was constraining the problem space for the for these package electronics through development boards like the Inkplay 2 that's also OSHWA certified and was part of the goodie bag on the open source hardware summit last year. And then one of my inspirations was the Flipper Zero on how people use those to like hack into and security test systems. But I was thinking, like, I don't have a use case for one of those myself, but I would like something in a similar form factor that I can use in my own context and to do things like maybe generative art and explore different ideas and approaches to technology. And my last inspiration was basically the SQRT, which is an art collectible from a guy in I think he was on an exhibition at Vancouver that mainly did generative art, but I took some of his approach because it was a similar case of a microcontroller instead of this 3D printing enclosure with an OLED screen. But it was not open source, but I wanted mine to be open source and have this functionality around art and things that people can use and engage with outside of just being technology, but more of the side of creativity and exploration. So if you can go to the next slide. So the ones you can see here are the 3 versions I ended up building through the last year. So from version 1, that's a really simple breadboard inside of a 3D printed case, all the way to the version 3 that's more complete with a PCB. I made and integrated everything inside. I have 4 buttons you can interact with the device. I built discrete debound circuits, and the charging circuit is all integrated now on that PCB. And then version 2 is an intermediate version where I had a PCB that integrated 2 off-the-shelf modules from Adafruit. Instead of for all the versions, I'm using their QT Py RP2040 board, which I found like quite handy and perfect for these use case. It's USB-C, quite small and fun. Can you move like 4 or 5 slides to the to one that's software and UI? I don't know what PowerPoint in the web is doing, but those were hidden. So yeah, can you move to the next one, please? So to do this, I use mainly CircuitPython, and I was really focusing on the software side to do something really modular and build something that other people can build in, mainly people that are newer to electronics and newer to building hardware and this exploration. And just to showcase the potential of the platform I was trying to build, I started with building Pong, a simple timer, a drawing application that is inspired by the Etch-a-Sketch and generative art sketch I made. I mainly follow these like application thing. You can go to the next one. And my interface was really inspired by the retro video games and like 8-bit pixel art and some of the Casio watches, because I was using 4 buttons. Usually Casio watches have 4 buttons as well to navigate and do most of the things. So now if you go to the next slide, we can see the 4 applications I built. They're like quite simple. It's a timer you can configure anywhere from 30 seconds to 30 minutes. Drawing application, also quite smooth and fun. I don't know why those are not moving. They are supposed to move. They were GIFs, but it's fine. And Then looking at the prototypes themselves in a bit more depth, it's you can move to the next slides. So yeah, version 1 was, as I said, like really focused on like easy assembly and compromising a bit of the robustness of the platform for having a really approachable version. And it really cemented like the how it looked, felt, and how it behaved, but it was lacking a bit on the interactive side. Then version 2 was a bit more advanced and a bit more interactive, implementing now the 4 buttons, but still quite approachable. You just get the PCB soldered, 2 ports to it, the QT and the charger, battery charger, so you can have a battery plugged in as well. And but it surely requires soldering now. But this really increased the durability of it. And then for version 3, it was now all integrated on a single PCB, and it looks something like this. And it's surely more complex, but I think it's still quite approachable for people to adopt. And yeah, I think that's mostly what the project it's about. Now it's finally live on GitHub. So if anyone wants to build one, it was quite a fun exploration. I learned a ton during this last year of building this device, like testing it myself, showcasing it in some talks, and yeah, I finally released all the files and it's out there in the world. I hope to get some people to start using it, and yeah, hopefully I'll get some community around it, building cool sketches and fun stuff on this cute tiny device. I also have one here. I can briefly demo like one of the features. So I have like this is the interface. You can navigate the different applications, and for example, with this one, it's this generative art demo. It's quite simple. It divides the screen in multiple segments, and you can have these really nice patterns going. So it can get more complex, a bit less complex, and yeah, just having a bit of fun with coding and electronics. And then my favorite, personally, it's these timers. So I try to build like a super easy timer to use. So it will roughly show you like 30 seconds with these charming squares. And yeah, it was mostly that. And I'm really happy to get certified by Open Source Hardware Association. It was one of my goals during the research. And yeah, that's roughly what my project is about.
That is really fun. I really love approaching it as a kind of standalone situation. That's such a fun way to. I don't need to be solo layout. That's such a fun way to think about it, of how we can make something that it doesn't need to have a million different things that it can do. It can literally just be that simple and still be so effective. So do you see yourself doing any more versions of this, or are you pretty happy with where it's at?
I think for now the challenge is to like really get it out there and get people to use it more and more. And so in this time I'll be focusing a bit more on like patching anything that's not working quite right, like demoing it more, trying to get more talks and just getting the word out there and people to adopt it. The main idea around it is to try encouraging people to be like, oh, that's kind of a fun device. I want to have one, and get to interact with the creation of technology by trying to use one. And my point was also trying to get people to make something in any way. So you can do a new case for it. You can do like hack the hardware, change the software, and that was my intention with making the device. So I want to get to that point first, and then I'll start thinking about new versions or new things, but just getting these started. So eventually I want to run workshops on building them and modifying them. And yeah, just seeing what people can do with the device.
Definitely. So you are in the Digital Futures program, which is a very exciting and very cool program. How has that affected your process of making? Like, have you done any kind of similar hardware projects before? Is this your first time working on something?
Yeah, this was my first time ever. Before I had done like the classic like bling an LED with an Arduino while I was studying computer science. But then during my time here, I got introduced by my teachers here. Shout out to them, Kate Hardman and Nick Pocket, amazing teachers. I was taking their physical computation class, and it was really cool to like see things in the world interact with like servo motors and quite a lot of things going during that class. So I was quite inspired to explore these things through that class, and I was like, okay, I need to pick something for my thesis for the master's. And around that time, the open source hardware summit also happened, and I got to go through OCAD University. So we went there. I had a blast, and I was like, yeah, I think I can totally learn this stuff. So I started learning how to design a PCB, how to 3D print, like design for 3D printing, and I ended up like building this device throughout the last year. So it was really a process of learning and experimenting to get to here. The first version was held with tape. The current version is not anymore. So yeah, it was a blast.
Incredible. I'm so happy to hear that the summit also had such a fun impact on your approach to making. That's such a fun way to, running the summit is super fun. So I always like to hear that folks get something out of it and really want to explore new ways because of it.
Yeah, for sure. And yeah, I hope it gets some more traction. We can get some more people to use it. And I'm still working on something, so a proper website will be coming. But for now, GitHub is where it lives. And yeah, if you want to make one or have any questions, please feel free to reach out to me. And yeah.
Amazing. Thank you so much, Juan. And we are going to thank you for coming on today and giving us a rundown on the TinkerPod, and really looking forward to seeing where it goes next and seeing folks make their own.
Oh yeah, thank you so much for having us.
All right, folks, we are at the end of our show for today. We got to hear about 3 really rad new projects that are doing such cool things. As always, we will be back again next month on the 3rd Thursday of the month, which will be May 20. May 20. I know this. I know how time works. Monday, May 22nd. Nope. I'm wrong. I'm lying. May 15th. I swear I know how time works. And we'll be back again with 3 new projects. It'll be a great time. It'll be our last one before the summit. So you'll also be able to see a bunch of these projects as well as other things and all kinds of ways that people are experimenting at the summit this year. We always encourage folks to bring their projects and plop them down on a table and talk to anyone who wants to hear about it. So that is always an option. Until next time, keep making stuff, sharing it, and finding new ways to iterate on it. We will see you next month.